So in these problems, we're going to continue proving trig identities. They're just going to be a little bit more involved. So, for example, prove A. The cotangent squared x plus 1 times the sine squared x minus 1 equals negative cotangent squared x. Okay, so in this problem, I'm going to want to try to basically rewrite some things. So we're going to start here with the left-hand side. So cotangent squared x plus 1, and then sine squared x minus 1. So the first thing I would notice is that this right here is one of our trig identities. So it's the Pythagorean identity that says the cosecant squared of x is the cotangent squared of x plus 1. So that's the first thing I'm going to do. I'm going to replace cotangent squared x plus 1 with cosecant. So this is going to be cosecant squared x times sine squared x minus 1. So we did a Pythagorean identity. The next thing that we're going to do, so remember we're trying to get to cotangent squared x. So having that sine squared x minus 1 isn't super helpful. So I'd like to do something with this part here. So remember that, actually, I'll do it in green here, this part here. So remember that sine squared x plus cosine squared x equals 1. And if I rearrange this a little bit, I could subtract the 1 to the left-hand side. So sine squared x minus 1, and move the cosine to the other side, equals minus cosine squared x. So that stuff inside that parenthesis that I underlined in green is really just a minus cosine squared x. So we have cosecant squared x times negative cosine squared x. And if we rewrite cosecant, so remember cosecant is 1 over sine squared x times minus cosine squared x. And I should really say that this step here too was also from the Pythagorean identity. So and then what I used here was the reciprocal identity. And so now, if I rewrite it again, this is going to be minus cosine squared x over sine squared x. And all I did here was some algebra. And then cosine squared x over sine squared x is cotangent. So I have minus cotangent squared x. And this is from the quotient identity. So I got to where I was trying identity. Oops, that's not how you spell that. Let me try to write that correctly. Quotient identity. So I got to where I was trying to get to. So let's try one more. So we've got secant squared x, cotangent x, minus cotangent x equals tangent x. So again, I'm going to start with that left-hand side, which is a more complicated side. And on that more complicated side, if you notice, both this first piece and the second piece have a cotangent x in it. So I'm going to factor out the cotangent of x, and I'm going to be left with secant squared x. Now, when I factor the cotangent out of the second part here, right, I'm taking it completely out, but I need to leave a placeholder. So that's where we put minus 1. And then secant squared x, so all we did so far here was some algebra. Then secant squared x is actually the same as tangent squared x. So we have the cotangent of x times tangent squared x. And that's the Pythagorean identity. And then if you remember, cotangent of x is the same as 1 over tangent of x. So I have 1 over tangent of x times tangent squared x, and that's the reciprocal identity. And then in this step, this tangent would cancel with the square, and we're just going to be left with 1 times tangent, or tangent of x. So all we did there was some algebra. And we got to where we were trying to get to. So we'll do one more. So tangent of x plus cotangent of x equals cosecant of x, secant of x. So again, we'll start here with the left-hand side. Now, the way it is, there's just two individual trig functions that we're trying to add. So there's not a lot we can do, but we can turn tangent and cotangent into sines and cosines. So tangent is sine x over cosine x, and cotangent is cosine x over sine x. Tapping my pen here. And so that's just from the quotient identities. And so now I have two fractions, and so what I want to do is make a common denominator. So my common denominator, so I can add the two fractions together, is going to be cosine x sine x plus something time over cosine x sine x. So to get from this bottom here, cosine x, to this bottom here, I had to multiply the bottom by sine x, which means I need to multiply the top by sine x. So I'm going to have sine x times sine x. And on the second one, to the bottom here was sine x. The bottom now is cosine x sine x. So I need to multiply the top also by cosine x. So I have cosine x cosine x. So all I did here was some algebra. And now I've got sine squared x over cosine x sine x. And I can add them together. So I have sine squared x plus cosine squared x. And so again, that's just algebra. And then we know that sine squared x plus cosine squared x is 1. So I have 1 over cosine x sine x. And that's from the Pythagorean identities. And then remember where we're trying to get to. We're trying to get to cosecant x, secant x. So I could split this into two fractions. 1 over cosine x times 1 over sine x. So again, I just did some algebra. And then 1 over cosine x is, in fact, is secant. And 1 over sine x is cosecant of x. And so that is the reciprocal identities. And if you notice, that's what we wanted up here at the beginning. Here we have cosecant written first and then times secant. Because it's multiplication, it doesn't matter. These two things are exactly the same. So you just want to be careful in these problems. You want to start with the left-hand side and then try to work it. Try to keep in mind where you're trying to get to so that you can get there, but you're always using for these right now, you're using the quotient, the reciprocal, and Pythagorean identities. We're going to learn about more identities starting in the next section of the textbook.